Hello and welcome to my video. Today I'm going to talk about the different types of computer languages. The first type of language that we have is machine language, and machine language is going to be computer readable language, and it's only going to consist of the binary digits 0 and 1. If we look over here on the right, we see this picture that has a depiction of machine language. On the left, we have the memory addresses where the instructions on the right here are stored. And as you can see, they are just sequentially going up in memory address by 1 each address. And on the right here, we have some instructions. And if you see, these lower ones you can't really see, but there's like this ... because there's, well, probably 64 bits here for each instruction. But if you look at these top ones, you can see there are some bits that are set. So when we do different instructions, such as these instructions you see over here, these are machine or assembly level instructions over here. But these instructions will be translated to this machine code over here, and the machine code is just going to have certain bits set in these 64-bit instructions that tells the computer what to do. And this runs directly on the hardware. So when you hear computer scientists say, well, computers can only read zeros and ones, this is what they are talking about, because computers can actually only read zeros and ones. And that is what these zeros and ones over here are. They are the instructions that are going to directly run on the hardware. And they're not really human readable. Technically, they are human readable, but you would have to sit here and decode all these each one of these instructions one by one, and that would be a massive undertaking. So technically, yes, they are human readable, but they're not quickly human readable. The next type of language we have is going to be an assembly language, and this is going to be one level of abstraction above the machine language. And assembly languages are going to consist of only primitive instructions. If we look over here, we have some different instructions right here. We have like the equals and LDA, STA, LDA, STA, the jump here. These are all different assembly level instructions. I'm not going to get into what they do, but this is what an assembly language will look like. They're primitive instructions, meaning that they do primitive things such as move data from memory into a register, or add two numbers, or multiply two numbers, etc. Each instruction in assembly language is going to do one thing and do one thing very well. And assembly languages are going to get assembled into machine code. And to do that, they will use an assembler, and the assembler is a computer program that is going to translate the code written in assembly language into a machine language. It's going to turn this assembly level language into this machine level language. And this is human readable because, well, instead of just having a bunch of zeros and ones for our instructions, well, over here we have actual instructions that are using characters, and they're much easier to read, but not necessarily the easiest thing to read. But these type of languages are going to give us a lot of control over our system because they're only doing primitive instructions. We will be able to do the exact instructions that the chip manufacturers of the processors made the processors do. We can combine a bunch of instructions to do more complex instructions, but in order to do something like, say, a loop, where in another high-level language it may be a single line to start a loop, well, in an assembly-level language, you're going to have to combine a bunch of primitive instructions to do that loop. And lastly, we have high-level languages, and these are going to give us a high level of abstraction away from the machine-level language. It's going to combine a bunch of these assembly language instructions to make more abstract instructions, such as loops, or if statements, if else statements, etc. And these type of languages are going to be either compiled or interpreted. And a compiled language is going to be a language such as C++ that you write your program and then you compile it or turn it into machine language and then you run the program. And to do that, it would use the compiler, which is a computer program that translates code written in high-level languages into machine language. But we also have what are called interpreted languages. And interpreted languages are going to be things like Python. In an interpreted language, you don't have a compilation step. When you are running your program or your script, at that point, each line will be translated into machine code when the interpreter hits that line. So you will be transforming your code into machine code during runtime. With an interpreted language and with a compiled language, you would be turning your code into machine code before runtime. That is a big difference between compiled and interpreted languages. And to do this interpretation, interpreted languages will use an interpreter, and an interpreter is just a computer program that directly executes programs written in scripting languages. And here is a chart that kind of shows you the differences between the languages. We have a high-level language, which is going to be something like C or Java or Fortran. These languages can then be turned into assembly language because they are just combining a bunch of instructions from assembly languages, and then this assembly language goes directly down to the machine language, or the zeros and ones that the hardware can actually run. And that is all that I have for you for this video. Thank you so much for watching, and I will see you in the next video.